So this is the Lab Midterm Retake, and I'm going to build it here on tinkercad. The first thing I want to point out is that you can't measure current if you plug two ends of a multimeter into the same node. Remember that these lines here, the ones that are circled in green, are all a single node. So you can't just plug them into the same node and expect to get a reading. What you can do is remove a wire like this and then replace the connection with another wire that connects it back to the multimeter, and then that's how you get your current readings. So anyway, let's start building a new circuit here. So first thing, of course, is to pull out a breadboard, and then we have 1, 2, 3, 4, 5 resistors. So I'm going to place them at 5, 10, 15, 20, 25. Okay. And this power source, pull that out here. I'm going to connect the positive end here, mark it with red, and then the negative end here, mark it with black. Okay, I'm going to first adjust the values on these. So I just need to remember that 1, 2, 3, 4, 5 goes left to right. You don't really need to rename it. So let's change the resistance here. 1 is 3.6, 2 is 5.1, 3 is 2.5, 4 is 1, and 5 is 2.2. I noticed that I know the names might be a little confusing, so let me just change the name for this, and then that way I'll just be able to change the name. Okay, so yeah, this becomes 1, 2, 3, 4, 5. Okay, names didn't change for some 2. But it doesn't matter because that's irrelevant. So now that the values have all changed, let's start connecting these. What I like to do is to think of the left side, the bottom side, as positive ends for reference, and the top as the negative ends for a resistor. And you'll remember that anything that discharges power, like this battery, the current goes from negative to positive, but anything that takes in power, the current goes from positive to negative. So it's really easy to visualize. You can mark it down on a piece of paper if you want, but we can just see that the current goes this way and then comes back down. So the positive ends of these resistors would be on top and then the negative on bottom, and for this R1, the negative is just connected to the negative here. So let's make our first connection. I'm going to start with R1. The negative is connected to the negative end of this resistor, and that's really simple. Just pull out this wire here. I'll mark it with black. The next connection, I'll connect R1 to R2. So this is the positive side now, and connected to the negative side of R2. So positive side is here, connected to the negative side of R2. Okay. We could keep going. R2 is connected to R4 and R5. So this is the negative end connected to the negative ends of R4 and R5. So you could go ahead and just pull this out here and then pull this out here. It doesn't matter how you guys do it. You could even just do it like this. It's all the same because they're going to be connected to this. This is all one single node. Now I'm going to connect the positive end of this battery or power supply to the positive end of R2, mark that with red, and then you'll see that this is also connected to R3. So the positive end of R3 comes over here, and the negative end of R3 splits into the positive ends of R4 and R5. So this is the negative end of R3 going into the positive ends of R4, and R5. And that should be everything. So if I did everything correctly, this should give us a value, and the voltage is 11 volts. So let's see if it works. Okay, let's see where I messed up. So, oh, okay. Here we go. Wrong one. Okay, so this is giving a reading of 1.98 milliamps, which is the correct reading if you do the calculations with the circuit. So now let's take the voltage and current readings of everything. Again, you're just gonna need a single multimeter. You could get multiple if you want, but it's all the same to me. So to make sure you get a positive value, it's really simple. You just connect the negative end to the negative side here, and then the positive end to the positive side. Remember that the bottom is being referenced as positive in my circuits. This is giving a reading of 7.12. And you could just, when you're doing these readings, you don't have to change the color wires. 3.88. And if you want, you could use KVL to verify this. It doesn't make a difference. So R3, 3.04. R4 and R5 are, remember, they're in parallel, so we should expect the same reading. Let's see if we do. 837 millivolts. So you'll notice that I got a negative number because I accidentally connected the negative end of the multimeter to the positive end of the resistor, which is no big deal. Just remember to leave it as a positive number, and I'll do the same thing. You'll see that it's the same value. So okay, voltage is measured in parallel, so you just stick one end to one end of the resistor, other end to the other end of the resistor, which is pretty simple. Now let's change this to volt current, so we're measuring amperage. Now remember, you can't just stick the two ends of the wire into the same node, because that won't give you a reading. It's what you can do potentially is to move this wire over here so that this is not directly connected to the power supply, and you could go ahead and plug one end right here and then plug the other right here, and that should give you a reading 1.98, which is what we should expect to get. Another more direct way of measuring voltage is even to connect it like this. Amperage, excuse me, 1.98. And if you want to simplify it even more, just go directly like this. Now, for this current, you don't really need to look at a multimeter. You could just look at the power supply itself, and because it gives you the current. But for other parts of the circuit, you're going to need a multimeter. So okay, let's do the current for R2. So the current flows here, goes through R2 and then splits off, and it also goes to R3. So if we do the same thing that we did with R1 and just remove this wire and connect the multimeter in here, that's actually not going to give us the correct reading. It's I'll demonstrate like this. So this is actually going to give us the reading for the 1.98, which is the sum of the current that goes through R2 and R3. So to fix this, or to actually properly measure it, you're going to do what we did before. You connect this here. So it's not directly connected to R2 and R3, and all you can do is just connect this to R3 and connect this to R2, and you get the same result. This is still going to have the same current, and right here you could see that if I just remove this wire and connect this here and connect this here, you'll see that this is actually a significantly different value for R2, 761 microamps. So that is how you measure the current for R2. I'll put this back here, and I got a negative sign because the signs were switched. So if I do it like this, you'll see that it crosses over each other, and I should get a positive value, 1.22 milliamps for R3. That's the current running through R3. And now let's take a look here at R4 and R5. So R3 is connected to R4 through this wire, which means we could go ahead and just disconnect. Go here. This is going to give us, I think, a negative value, right? 837 microamps. That's pretty reasonable. And R5, again, that's connected to this wire. Go ahead, delete that. This is again going to give us a negative number, but its magnitude is the same, 380 microamps. And if you verify these through KVL and KCL, you should be able to verify that all these values are correct. So that's how you do the this circuit on tinkercad.